Okay, so again, the goal for what we're doing in this project, we are going to compute the Collatz sequence for the numbers 1 to 10, though 10 is actually just means like a generic upper bound. We're going to compute the Collatz sequence for the numbers 1 through 10 and find the number of terms in each Collatz sequence and then store that output in an array and then like print that array. Okay, and maybe do some other things with it as well. So the output of this whole thing needs to be an array. So actually first we're going to say n is equal to 10. So we're going to look at the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now I need to have an array of 10 elements. So I'm going to say output is equal to numpy dot zeros of length 10. So now this is an array with 10 entries, each one is 0. And if we just want to print, see, when you're first learning, and even now, because of the way it's indexed, you want to make sure, I just want to double check that numpy.zeros is going to give me a list of 10 elements and not a list of 9 or 11 elements. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, remember, I don't want them to be decimals. I want them to be integers. That's not really going to, this is more of a taste than anything else. Oh, I misspelled this. T-Y-P. Okay, there we go. All right, so I don't need to have that anymore. Okay, so now what I'm going to do is I'm going to use the following loop. I'm going to say for index item, or maybe value, for index value in enumerate output. Okay, I'm going to, for each element, I'm going to compute the Collatz sequence. So I want to be careful here. So if I print the index, I'm going to have the 0th index, the first index, second index, so on and so forth. But what I need to do is I want to compute the Collatz sequence, like for the first thing I want to compute the Collatz sequence, not for the number 0, but for the number 1. So here I want to compute the Collatz sequence, not for the number 1, but for the number 2, and so on and so forth. And so I'm just going to say num is equal to index plus 1. And now I'm going to print num. I'm going to write this out here. And now what I'm going to do is I'm going to say output, this is just a test case, output of index is equal to, and what is eventually going to go here, though not quite this way, is going to be however many terms in the Collatz sequence. So I'm just going to put a number here, 5, just to sort of see what's going on here. Okay, and now I'm going to print, well, okay, so that's kind of what's going to happen. Okay, so now for each num, so we're going to have 2 nested loops. So now we have our outer loop, which goes through this list of length 10. The first index of that list is 0, and so the first index of the list is 0, and in the output list in that slot, we want to put the number of terms in the Collatz sequence for the number 1. The second index is 1, and in the corresponding output list, we want to put the number of terms in the Collatz sequence for the number 2, and so on and so forth. So we're going to be, if we're on index k, we want to compute the Collatz sequence for k plus 1. So that's what this is. Num equals index plus 1. This is the number on which we are going to be computing the Collatz sequence. Okay, so now we're going to say, so the number of terms, I'll say in terms, it's always going to be at least equal to 1. So in terms is going to be equal to 1. And now we're going to say while num is greater than 1, we're going to do something. We're going to do this Collatz sequence. If num, if it's even, num equals num equals num over 2, else num equals 3 times num plus 1. Okay, and each time we each time we go and compute a next, we're computing the next term of the Collatz sequence, so I need to increase the number of terms. So in terms is equal to in terms plus 1. Okay, so now we've incremented. So, okay, so what's happening here for index value and enumerate output? So we're going to get, if we just go through what's happening in this list, the first index is 0, the first value is 0, num equals index plus 1. So num is equal to 1, the number of terms is equal to 1. So now, while num is greater than 1, so we're computing the Collatz sequence for 1, while num is greater than 1, if num is even, we're going to divide by 2, else we multiply by 3 and add 1. And then here we increment the number of terms in the Collatz sequence. Okay, so again, we're doing this inner loop for every index and value in the output array. So now we're going to be done. Once we get out of this while loop, once this while loop completes, that is when num is equal to 1, we now know how many terms are in the Collatz sequence for that number. So now we're going to say output of index is equal to in terms. Okay, so now what's going to happen, now we're done with the outer for loop. We're done with this iteration of the outer for loop. So now we're going to increment, we're now going to have index being equal to 1. The value is going to be the next value in the output, which is 0. And we have num equals index plus 1, so now num is going to be equal to 2. Number of terms is now reset to being equal to 1, and so on and so forth. And really, we're not really going to use this value here at this point, but I thought we might have, so that's why I did it like that. But I just kind of prefer doing it this way anyways. Okay, and so now we can print output, except I'm going to make in equals 1 now. So it's just going to be a list of one item, okay, and it's going to be the Collatz sequence for the number 1, or the number of terms in the Collatz sequence for 1. So when I run this, my output should just be an array with one item in it, which is 1. Oh, well, so here's a problem. I had a 10 there, and I needed to have an in there. Okay, so, all right, let's run it again. I get 1. Okay, if I want 2, so the number of terms in the Collatz sequence for 1 is 1. The number of terms in the Collatz sequence for 2 is 2. So this is just basically testing the code. Whoops. And if I run that again, that's what I get. Okay, let's think about 3. The Collatz sequence for 3 is going to be 3. We multiply by 2 and add 1. So, we multiply by 3 and add 1. So that's going to be 10. We divide 10 by 2. That's 5. We multiply this by 3 and add 1, that's 16, then 8, then 4, then 2, then 1. So now 1, 2, 3, 4, 5, 6, 7, 8. When I run this code, the next one should be an 8. Whoops. When I run this code, the next term, when I change this to a 3 and run this code, the next term should be an 8. Okay, and so now I think that is all of the lecture part that I want to talk about this week. I will talk about matplotlib next week and SymPy eventually as well. I know it had SymPy and matplotlib this week, but I think the assignment that I'm going to have you do this week is going to be enough to really get your mind and really help you understand all of the things that I want you to understand this week, which is arrays and basic input and out, or basic program control, for loops, while loops, if, else statements, and that sort of thing. Because one of the things that you're going to be doing on the homework assignment, is basically just having this list here, but also you're going to print some other stuff instead of just the output. I'll have you print like the maximum in the list and the minimum in the list, that sort of thing. But essentially you're going to be able to just more or less copy all of this code right here, and you'll just have to change the bottom a little bit about what's going to be printed out. But the harder part of this project is going to be the following. You're going to, for every, you're going to have this whole thing is going to be inside another loop. And what you're going to do is, for n equals 1, you're going to compute this, for n equals 1, you're going to compute this, it's going to be 1. For n equals 2, you're going to compute this. For n equals 3, you're going to compute this. What you're going to do is, for n equals 1, you're going to compute the average and store that into the first element of an array. For n equals 2, you're going to compute the average and store that, the average of this list, and then store that into a second array, and so on and so forth. Actually, it won't exactly be the average. It'll be the average divided by the number, divided by n here. Okay, so for example, when n is equal to 1, there is one item. So the the output for this part of the homework question, when n is equal to 1, there's one item in the list. The average is 1. So the first term will, in the output array for this part of the program, it would be a 1. Now, if I run this when this is equal to 2, there are 2 items in the list. The average of this list is 2 plus 1, that's 3. So the average of the list is 1.5, but there's 2 elements in the list. So we're going to do 1.5 divided by 2. That would be the output. Then we're going to look at the number 3, for example, and that's 1, 2, 8. The average, 8, 9, 10, 11 is 11 thirds. So it's going to be, the output would be 11 thirds divided by 3, and so on and so forth. So as you can see, there's a pattern. There's like a formula for what this is going to be, and you can use one of several NumPy functions to compute that. I hope that makes sense. If not, just ask in the comments and that sort of thing. I'm working on writing up the assignment now. Today is Tuesday, and I'll have it posted sometime today.